and welcome to our Pint of Science event on how the University of Sheffield is tackling the big challenges of our time. I'm Ilaria Bellantuono, Professor of Musculoskeletal Aging at the University of Sheffield, and I'm delighted to be your host this evening. As you may know, Pint of Science is a worldwide science festival which usually brings researchers to your local pub, cafe, and space to share their scientific discoveries with you. This year, however, we will be on your screen instead. I still hope you have a drink with you. Tonight's event is What Can Research Do for Us and Tackling the Big Challenges. And we will explore how the University of Sheffield new flagship research institute are working to decarbonize industry, improve food sustainability, pioneer new treatment for neurological conditions, and help us all live healthier life for longer. Our excellent panel this evening includes Dr. Francesca De Faveri from the Neuroscience Institute, which brings together internationally recognized expertise in medicine, science, and engineering to improve the life of patients and family affected by neurological, sensory, and developmental disorders. She will be followed by Dr. Liz Williams from the Healthy Lifespan Institute, which unites more than 140 researchers in a mission to help people live life free from age-related disease and frailty for longer. Dr. Ellie Harrison from the Institute of Sustainable Food, which is finding dynamic solutions to the global challenges of food security and sustainability, will be next. And then finally, we will have Dr. Alastair Buckley from the Energy Institute, which works with government and industry to develop new sustainable energy technology, support decarbonization activity, and stimulate behavior change in how we produce and consume energy. We only have an hour this evening, so each of our speakers will be briefing their presentation, and then we will have time for questions from the audience. They will be live on air, and you will be able to ask a question to all of our panelists. You can also tweet with the hashtag Pint21. So without further ado, I will go to our first speaker, is Dr. Francesca De Faveri. Francesca is a postdoctoral researcher in the Department of Biomedical Science, and she researches sensory neurons and is working to understand the neurological processes involving in hearing loss with the goal of developing therapies for restoring hearing. Francesca, over to you.
Hello, I am from Professor Marcotti's lab, part of the hearing research group at the Neuroscience Institute. Tonight, I will talk about how our laboratories are collaborating to understand the mechanisms underlying age-related hearing loss. Our ultimate goal is to develop potential treatments to prevent and cure age-related hearing loss. Hearing plays an important part in many aspects of our lives, and yet in the UK, 11 million people have hearing loss, with age-related hearing loss being the most prevalent cause. It is associated with a decreased hearing sensitivity, difficulty to understand speech, especially in a noisy environment, and impaired sound localization. Age-related hearing loss is a complex disorder caused by both genetic and environmental factors. It affects approximately 25% of people over 45 and 60% of people over 70. Despite the large impact of age-related hearing loss into modern society, there are currently no available diagnostic tools or therapeutic intervention. And this is largely due to the fact that we have very little understanding into the mechanisms underpinning age-related hearing loss. Currently, the therapeutic interventions to ameliorate hearing loss are hearing aids and cochlear implants. And while beneficial, this cannot restore all the features of hearing, such as the ability to appreciate music or to understand speech, especially in a noisy environment. Even more so in current times, face coverings make it even more difficult for people with hearing loss to understand speech. But how do we hear? Sound enters our ear and reaches a coiled structure called cochlea. Inside the cochlea are the sensory receptors hair cells, which are so called due to the hair-like elements which protrude from their apical surface. These are called stereocilia. Hair cells convert the vibration of their stereocilia, caused by sound waves, into electrical signals. Afferent neurons then transmit these electrical signals to the brain. Our research groups have specialized expertise to study the genetics and the physiology of the auditory system. So on a functional point of view, we can record the electrical currents from the hair cells while their stereocilia are vibrating. And then we can monitor how these electrical currents are transmitted to the afferent neurons to be delivered to the brain. We can also study the morphology and the organization of the hair cells and go into the very fine details of the structures of their stereocilia. So by understanding the mechanisms of development, function, and aging of the auditory system, we hope to develop therapeutic intervention to prevent the different forms of hearing loss and deafness. When hair cells or the afferent neurons stop functioning, we experience hearing loss. Different factors can damage the hair cells and neurons, and among these are the repeated exposure to loud sound, drugs used for treating other medical conditions, and aging. Genetic factors are often associated with a predisposition to develop age-related hearing loss. So we are trying to identify the genes associated with susceptibility to age-related hearing loss. Once we have identified such genes, we want to understand how their mutation affects the function and the structure of the aged auditory system. So, for example, some genetic mutations might cause the hair cells to die or may damage their stereocilia, thereby impairing their ability to detect sound vibrations. Ultimately, we want to develop gene therapy as a tool to reintroduce the mutated genes and therefore restore the auditory function. At the Hearing Research Group, 8 group leaders are collaborating to understand the mechanisms underlying age-related hearing loss and develop treatments. Away from the lab bench, we have developed a range of outreach activities to explain hearing and hearing loss to a wide range of audiences. Until our hands-on activities can resume, we invite you to follow our research updates on Twitter. Thank you very much for listening.
Thank you very much, Francesca. The next presenter is Dr. Liz Williams. She is a senior lecturer in human nutrition based at the Department of Oncology and Metabolism. Liz researches the role of diet in the prevention of chronic disease and the promotion of healthy lifespan. Liz, over to you.
Thanks, Ilaria. So, hello everyone, I'm Liz. I'm an academic and a registered nutritionist, and I work within the Healthy Lifespan Institute. And in the next 5 minutes, I'd like to tell you a little bit about my research interests. So first of all, the mission of the Healthy Lifespan Institute is to lead multidisciplinary scientific efforts to tackle multimorbidity and frailty. And we're taking 3 interlinked approaches to do that. We're looking at the biology of aging, the causes of aging, so we're taking lab-based approaches, but also looking at data-driven approaches to try and determine what the causes are in terms of our societal and behavioural environments. We're designing interventions that will help tackle aging, and those interventions are both lifestyle interventions and more pharmacological approaches to try and reduce the diseases that we associate with aging and the characteristics of aging. And most importantly, our researchers are working in partnership with key stakeholders. And those key stakeholders are the older adults themselves, third sector organisations, and policymakers. And so what we are aiming to do is to address meaningful research priorities and make sure that our research has real world relevance. The one ambition that I'm sure that we all share is to live a healthy, active life for as long as we possibly can. And we know that the rate of aging is variable and highly malleable. So some of the factors that influence the rate at which we age and the rate at which we develop chronic disease include things like our socioeconomic status and the environment in which we live in, and also things like the amount of stress we have in our lives. Some of those factors we can't control, but other factors we can. And our diet and our lifestyle, we do have some control over. And my primary research interest is understanding the role of nutrition in health, and specifically understanding what is the best diet for healthy aging? The nutritional secret to aging does not lie in a single food or a single nutrient, but seems to lie in a pattern of dietary behaviour. And the one thing you could do today to improve your chances of living a healthy older age is to switch to a more plant-based diet or a more Mediterranean diet. And numerous studies have shown that adherence to a more Mediterranean dietary pattern reduces the risk of cancers and cardiovascular diseases and dementia. And this dietary pattern is associated with a high intake of fruit, vegetables, cereals, nuts, olive oil, a moderate intake of fish and alcohol, and a low intake of meat products and processed foods. So the key feature of this diet is that it's predominantly plant-based, and this is a diet that's likely to be good for both you and for the planet. And this leads me to the one area of research that particularly interests me around dietary protein. So with a group of researchers from around the UK, we explored the role of protein in aging. So dietary protein is the macronutrient in our diet that is essential for muscle strength and function. As we get older, we lose our muscle mass, and we can become increasingly frail as we become older. And diet is an important way to tackle that, alongside exercise and resistance exercise being most important. In the UK, we're recommended to consume 0.75 grams of protein per kilogram of body weight. And that translates to about 45 grams of protein for a man or 55 grams of protein for a woman. However, there is increasing evidence that we need more dietary protein as we age to preserve our muscle. In our research, we've used national data and supermarket data to profile consumers' behaviour. And we looked at consumers over the age of 40. We found that the majority of people did achieve the current recommendations for protein, but very few met those higher recommendations that we think are needed. Perhaps not surprisingly, we found that the majority of the protein in our diets comes from animal protein in the form of meat and dairy. We've conducted focus group interviews with older adults and middle-aged populations to understand the attitudes towards protein consumption, and found that people had a very poor understanding of what protein does and how much you need. And consumers also considered that the amount of fat, carbohydrate and sugar in the diet was more important to them when they were selecting what foods they were going to purchase, and that really protein wasn't something that concerned them. There was also very mixed views on the value of plant-based proteins in the diet, and many viewed it as a secondary source or a lesser source of protein. To me, this presents a real public health challenge. The research suggests that protein intakes are inadequate in older age. However, most of the protein that we consume is coming from animal sources, which isn't good for our health or for the environment. And so we need to find strategies to optimize protein intakes whilst not increasing the consumption of animal products. So I think we need to increase consumer awareness of the importance of protein in the diet, especially as we get older, and to improve attitudes towards the consumptions of plant-based proteins such as pulses and beans and nuts. There's still quite a lot of nutritional science to understand with regards to the impact of protein on appetite, for example, and also we're still teasing out what is the optimum amount of protein that we need and what is the best form of protein for our health. And I'd just like to leave you with this quote from Roosevelt. So old age is like everything else. To make a success of it, you've got to start young. And I really think that aging well is something that warrants attention throughout the life course. Thanks very much.
Thank you, Liz. So our next speaker is Dr. Ellie Harrison, an evolutionary microbiologist from the Department of Animal and Plant Sciences. Ellie researches the ecology and evolution of microbial communities and is working to understand soil health and its implication for food security. Ellie, over to you. Thank you.
Thanks very much. So yes, I work for the Institute of Sustainable Food, and I don't think I need to spend time convincing anyone that food is a really important thing to be thinking about. We've actually just seen a really brilliant example of the way that food, and not just calories, but the kind of food that you have access to, is a wonderful determinant of your health and longevity. But our food production systems are in trouble. So for the last sort of 70 years, we've seen a major innovation and revolution really in the way that we produce food. But it's left us with a food production system that is incredibly complex. It's very unequal, both within our societies, but across the world as well. It's incredibly fragile, so prone to disruption from major climatic events that are becoming more and more common. And it's devastatingly unsustainable. So about 30% of greenhouse gas emissions come from agriculture, and we have a lot of pollution associated with it, but we're also using up resources, fundamental resources like soils, for example, at a rate that they can't be replenished. So what does it look like to create a food future for ourselves that moves away from these challenges? Well, we're going to need to produce something that relies much less on inputs from things like fertilizers and pesticides that are responsible for much of the pollution that is associated with agriculture. We need to address the way that the whole system, this whole complex network, is structured so that we can reduce inequalities throughout the world and within our own communities. And we need to increase the resilience of these agricultural systems because of that increasing issue of a changing climate that's simply going to get worse and worse and potentially cause greater disruption. Unfortunately, we're also going to have to do this whilst feeding more people. The population of our planet is somewhere hovering around 8 billion at the moment. By 2060, the UN estimates will be about more like 10 billion. So we need to rethink our food structures whilst trying to work out how to feed an extra 2 billion people in the coming decades. And we also probably have less land to do that with. We've seen a lot of land that we've relied on for agriculture being lost due to the unsustainable practices that we have. So we need to do more with less, but using less of those polluting techniques that we have relied on. So we are facing a really monumental challenge in our agricultural industries. And the Institute for Sustainable Food really believes that in order to tackle this complex, this multifaceted challenge, we need to bring together stakeholders from across this entire food network. And we're at a university, so of course this involves multiple academic disciplines. So we have partners within every single faculty at the university here, so across the sciences, from bioscience to engineering, within social science and politics, for example. But it also forms a hub in which those academics can work with and collaborate with people, stakeholders from across that food network. So the producers of food, the farmers, the consumers, and those processes that are involved in those many intervening stages that we kind of gloss over when we think about this sort of a simple model of food production from farm to fork. There are, of course, many intermediaries working in these networks. And the kind of work that we're doing in the Institute is ranges from looking at individual crops, so looking at how we can breed crops that are more resilient to changing climates, for example, crops that are more resilient to drought. We have policymakers working with farmers, thinking about how to structure incentives into future agricultural policy in Europe in order to encourage changes in agricultural practices. And we have scientists working with communities here in Sheffield, looking at how we can utilise urban land for food production in various different innovative ways. So in my work, I am interested in microbes. I'm a microbiologist purely at heart, and I came to this field through a love of the roles in which microbes can play in our ecosystems. And microbes really underlie all of the plants that you look around and see growing today. They help them grow. And so we can look at the way that those interactions between plants and microbes occur and try to build on this in our agricultural systems. Unfortunately, for the last sort of 70 odd years, we have increasingly moved away from the roles that microbes play for the plants that we grow. Things like providing nutrients, for example, now we replace that with fertilizer, or crop protection, now we've replaced that with pesticides. So I have a couple of projects with the Institute. So with one of my projects, we're looking at the ways that we can make better nitrogen fixing partnerships between microbes and plants. And so this plot here, if you, oh look, I've got a little arrow. Perfect. So you can see these are root structures. This is a bean plant. And if you happen to be growing peas or beans in your garden or your allotment, and you pull those plants out of the ground, you'll find these structures on the roots called root nodules. And these are special plant-made structures that house a friendly symbiotic bacteria called rhizobia that fixes atmospheric nitrogen and turns it into a fertilizer, essentially, that the plant can use. So we are looking at ways that we can make this association stronger and more effective in the field. In another project I'm involved with, we are looking at how we can translate the natural disease-resistant qualities that microbial communities can give to their plant hosts into different forms of crop production, for example, hydroponics. So hydroponic systems, like you see illustrated here, are where we grow plants or crops usually in a sort of liquid-based medium. So rather than growing them in soil, we're growing them simply by passing through liquid that they can get their nutrients from. But the problem with these systems is, whilst they're really great for sustainability, they're very low water use, they're very low energy use, and as you can see here, they can be very efficient with land use. They're really susceptible to disease, and so they require a lot of inputs, and it also prevents us from growing a lot of diversity of crops under these kind of systems. So we want to see whether we can take the natural disease-resistant qualities that you find in soil microbial communities and translate this into systems such as hydroponics to try and produce a more sort of natural approach to a sustainable farming practice. So thank you very much, and I'm looking forward to questions.
Thank you, Ellie. So our final speaker is Dr. Alastair Buckley. He is a senior lecturer in organic electronics and the Department of Physics and Astronomy. And Alastair researches optoelectronics and photovoltaics and is working to find ways of improving solar electricity generation and performance. And over to you, Alastair. Thank you.
Thanks very much. So yeah, the final talk here is about kind of energy and energy systems for Great Britain. I guess I started out, as Illyria said, as a kind of material scientist, almost a chemist actually, and now I'm more working in a kind of data science role, and work very closely with industry, with National Grid in particular, and other companies. I put one at the bottom here, Advanced Infrastructure, who have stolen some of the slides from. So I'll start by kind of talking a little bit about the problem of the kind of transition from fossil fuel-based electricity generation to renewable electricity generation, how we're helping here at the university as part of the Energy Institute, and I guess a little bit about the wider role of university research in some of these problems. So yeah, let's start with the kind of national scale problem of trying to transition to a kind of fully renewable solar energy and wind energy system in the future. So if we go back maybe, well, only 10 years actually, we'll have an electricity system which looks a little bit like the map on the screen here. The red dots are fossil fuel-based power stations. There's not that many of them, and they're connected together by a set of wires called the electricity transmission network. And kind of deeper below that set of wires is another set of wires which connect to your kind of homes and businesses and factories, and that's called the distribution network. And in the past, all the electricity was generated by these power stations, and it flowed in one direction only, down into the distribution network to give you the electricity that you need. But over the last 10 or 15 years, that system has changed quite a lot, actually, a massive amount. And now we have wind farms, mostly off-sea, but quite a lot onshore as well, especially in Scotland. Wind farms generating a lot of electricity, contributing to a kind of massive decarbonisation in our electricity production. And also solar, which is much more widely distributed, all on land at the moment. And the size of the little circles here kind of tells you how big the kind of power plants associated with wind and solar and the fossil generators are. So we've seen this big change. And in the future, it's going to change even more. We're going to end up with an electricity system that is really very, very complicated, where the generation is distributed within the system. And we'll also have kind of control technologies such as batteries. We'll have electric vehicles moving electricity around the network, and we'll have other energy kind of vectors such as hydrogen, which is used to store some of the excess electricity and then reuse it. So we've moved from an electricity system which is pretty straightforward. There's an organisation that's responsible historically for keeping the lights on, and that was National Grid, and they had to make sure that the demand for electricity was always satisfied by turning on and off the power stations. But now they've got a much more difficult problem, because they have to satisfy the demand for electricity, but they have a lot of uncertainty in where that electricity is going to come from. Some days it'll be windy, other days it'll be sunny, and some days it'll be windy and sunny. So our role within this kind of problem is to, well, and for the last 5-6 years we've been working with National Grid. What we do is to provide a measurement of the solar electricity generation within the network. So on the little graph on the right here, you can see the different contributions of electricity generation. We've got nuclear ticking along at the bottom. No one really wants to turn off nuclear power stations. And then we've got wind, which kind of changes over kind of days and weeks. So sometimes it's very windy and sometimes it's not windy at all. And then we've got interconnections to different countries in Europe. And then we've got gas, and it's the gas power stations which kind of have to make up the slack when the solar and the wind and the nuclear can't satisfy demand. And then at the top, we've got the solar generation. Now, the solar generation is totally weather dependent, but it's also historically totally invisible to National Grid. They can't measure that directly. So what they actually see on their kind of control board is the net demand. That's the total demand, which is the solar bit plus the bit that they can see. And what we do is provide a measurement system which allows them to have visibility of the national solar generation. And that helps them much more accurately predict what generation will be needed in the future, primarily from the gas-powered power stations. So we've developed a kind of national measurement system for the solar generation. So a picture here is a representation of that solar generation during a day back in 2017 when Hurricane Ophelia came across the country, and you can see a band of just going to start up again now, a band of kind of dust that came across from the Sahara that then passed across the country right now and reduced the solar output. So we've got this kind of spatially resolved measurement of solar generation, and we've developed that by working with different companies with different data sets to pull together the map, and that kind of real-time data feeds into the control room of National Grid and helps them predict what the net demand is for electricity. So that's the work we've done, and we're continuing to work with other companies like Advanced Infrastructure to kind of build a kind of additional digital services to support the kind of transition from this kind of fossil fuel supplied energy system to one which is much more distributed and complicated. And actually it's the information systems associated with that distribution of the sources of electricity generation, which is actually one of the bigger challenges for the kind of system operator. So just finishing up, so I guess that universities have a really important role to play here. And it's not just about the technologies that form part of the energy system, but it's also about all these digital services and platforms and data science that allow the thing to fit together and work properly. And universities are in a unique situation because they very often have access to data that other organizations can't get. They've got access to skilled people, and in particular, and as Ellie was mentioning, new methods from different disciplines. So I'm basically a chemist by training. I'm in a physics department and I'm doing research here, which kind of links between geography and engineering. So it's all of those mix of different skills and disciplines, which makes for a unique place to do this kind of research. We also have access to resources, but we also have a remit to make the new knowledge publicly available, which is hugely important when we've got challenges which affect everybody. So that's the end of my talk, and pass back for some questions.
Thank you very much, Alastair. So we will now begin the question and answer sessions, and we will open the question to the public, to the audience. To submit a question, just simply type into the chat box to the right of the video. And if you want to ask a question to a specific member of the panel, include their name in the question. So to begin the discussion, I would like to ask the panel, so if you think fast forward 10 years, how far do you think you will be in addressing your challenge? And I'd like to start with Francesca.
Hello. Well, I think we can be very optimistic that in the next 5 to 10 years, we will have made some great progress. So we are working to identify genes associated with susceptibility to developing age-related hearing loss. And other labs at the Neuroscience Institute are doing the same for other conditions. The gene therapy technology is being developed. It's currently under clinical trials in the US, and it will surely follow very fast in the UK. And indeed, the University of Sheffield has been selected for the opening of a new gene therapy innovation center for developing this technology. So things are moving, and hopefully we will make progress very soon.
Thank you, Francesca. And Liz, what about healthier lifespan? How far will we be?
Yeah, I'm optimistic too. I'm optimistic in terms of our scientific understanding of the biology of aging. I think we understand a lot more, and I think now we've identified hallmarks that are associated with aging. So we know some of those biological mechanisms that we can tackle, and there's a commonality between many of the characteristics of aging. There are some promising drugs in the lab. Whether we will be at the point in 10 years' time whereby we will be able to pop a drug in order to try and reverse some of those signs of aging, I'm not sure, but I think we'll be a lot closer to that. And in terms of the direct sort of challenge I've got in terms of hoping that people will increase their plant-based proteins and improve their diets, I think, as we've heard, there's considerable environmental pressure for us to do that. And I think as a society, we've got massive challenges on our hands. And I think COVID has highlighted where there are inequalities within society that need to be tackled. We have a new obesity strategy. And so hopefully governments will get behind the agenda and really try and tackle inequality, tackle obesity and obesity related disorders. So I think we've got big challenges on our hands, but I'm hopeful that working together that we can do it.
Fantastic. Thank you, Liz. And Ellie, of course, environment is very much on everyone's mind. So where will you be in 10 years' time with food sustainability?
Okay, I'm going to start by being a bit pessimistic, and then I'll be optimistic. So I'm going to be a bit pessimistic to begin with, because we're really in a position where we need to act fast, and we need grand level systemic change, both generally for tackling climate change in general, but and which then impacts on our agricultural systems. So, I mean, I do think that we are going to be seeing challenges becoming harder and harder and harder throughout the decade as climate change really ramps up. And the question is, can we keep up with this? So the optimistic side of that is that I am increasingly seeing that we have farmers and consumers really getting engaged in trialing new methods, in experimenting with new practices, despite being, having generations of work, of working in kind of similar circumstances. And on the academic side, we're seeing an appreciation that we as academics really do not know enough to be making grand statements about what producers should be doing. Rather, we need to be working with and collaborating with producers and communities with expertise on the ground. And I'm seeing more and more, I'm seeing this kind of approach to research. So I'm hopeful that we can find sustainable avenues for new food production. But I think as years go by, the situation we're facing is equally going to get more challenging.
Fantastic. Thank you so much. Alastair, where will we be with energy?
In 10 years' time, I guess there's good things and there's bad things. So in the last 10 years, the carbon intensity of electricity has fallen to 30% of its value 10 years ago, which is obviously fantastic progress. But unfortunately, all the easy bits are done now. Oh, there is another good point, actually. Renewable electricity is also the cheapest form of electricity on the network at the moment, and it will only get cheaper. But we've still got a really hard task ahead, because heating our homes and heat for industrial processes needs to decarbonize too, and that's going to require a transition to using electricity. So we're going to just decarbonizing electricity is not the solution. We actually need to produce more electricity, and we need to be able to store it so that we can use it when we need it. And those points of transition are much harder to do. So it's kind of good news on progress so far. But actually, we're only really just starting in terms of the challenge, I think.
Very good. We'll watch you closely. So now it's time for questions from the audience. And we have a question from Toby, and he's asking a question for Francesca. So Toby is asking whether your research is also covering tinnitus.
Okay, well, I say it does and it doesn't. So I guess tinnitus is can be caused by different factors. So it can be associated with hearing loss caused by noise exposure or by use of drugs for treating other conditions. So maybe the genetic predisposition is not one of the possible causes, which would be easy to treat, achievable to try and treat with gene therapy. But our lab studies the physiology of the auditory system and what happens when hair cells or afferent neurons are damaged. So this would also happen in a tinnitus situation. So hopefully we can understand more of what happens when the auditory system is damaged and you experience tinnitus.
Thank you. So we have another question, and this is a question from Richard. Are there links or crossover between the 4 big challenges that you have been speaking tonight? So maybe I'll start with Alastair this time.
Yeah, of course there are links and crossovers. I just need to come up with one quickly to evidence that. I think the agricultural system and the energy system are intimately linked. Ellie talked about 30% of global greenhouse gas emissions associated with agriculture and food production. So thinking about the kind of logistical transport and supply chains associated with the kind of global food industry, that's intimately linked to the kind of energy system upon which those supply chains are built. So that's a good start. Now I can hand over
Absolutely.
quickly to somebody else.
Liz, you've asked a tough one, Richard. Liz, would you like to take it next?
Yeah, yes, I can see links and crossovers with all the 4 flagship research institutes. So I sit in both the Healthy Lifespan Institute and the Institute for Sustainable Food for quite obvious reasons. But, you know, lots of the research that's happening in the Healthy Lifespan Institute, there is crossover with neuroscience, and of course, you know, the big challenge, the big issue about climate change, about carbon, about the impact we're having on the global biodiversity. These are all interlinked issues, and I don't think that they're going to be dealt with in individual silos. I think we do have to think very broadly across our disciplines, and there is absolute crossover between these disciplines. So my interest in terms of I'm a physiologist by background, so I'm primarily interested in mechanisms associated with aging, but through that I've become more and more aware of the importance of sustainable foods, and so that is a real crossover for me personally. So yes, I think they are all interlinked, our flagship institutes.
Thank you very much, Liz. And we have a question from Toby, and this is for Alastair. So is battery storage critical for properly using solar?
Okay, I can definitely answer this one. To a certain point, it's not that important. So because solar generation peaks obviously during the middle of the day, and actually most electricity demand is during the day. So you can get to a certain point of usage of solar without having to store it. But when you go past a certain point, and that's about kind of 30% of your demand coming from solar, then you need to store it. So we're kind of starting to get to that transition point at the moment. And so in the future, when we're trying to use solar electricity for vehicles and for heating, then storage becomes really, really important. Absolutely.
Fantastic, thank you. So we have another question from Richard, and he is asking Ellie, what are your thoughts on lab-grown meat and whether it will ever be common?
I mean, I suppose it has a place in it's my doorbell. It maybe has a place in our diets. It's not something that I feel particularly that there's a strong need for. I think what we've seen already is that we need an increase in protein coming from plant-based resources. We do need to move away from meat production in a traditional cow-based way. I mean, beef, for example, is an incredibly unsustainable food product. The translation of energy from the plants or that they eat into the food that is produced is something like, you know, one kilogram of food for 8 kilograms of plant-based food that goes into that food production. But I'd rather keep the conversation talking about how we can look at the diets that we eat for both the benefits for the environment that they can have, but also, as we've seen, the benefits to our health that they can have. And this isn't a call for everyone to go vegetarian by any means. This is a call for shifting the balance of our diets towards a more diverse plant-based system to both help our planet, but also to help our health. And I am, you know, I'm someone that works primarily on legumes, which are a great source of plant protein, but also help the soils regenerate through adding nitrogen. So I'm a real pro-legume person.
Thank you. So our next question is actually for Liz. So are other food groups helpful or harmful as we age?
Yeah, so there's no particular foods that I would say are bad foods, and I ask this question an awful lot. As we age, we need a varied, balanced diet, as we all do need a varied, balanced diet. There are particular challenges as we age, because as we age, our appetite declines. And our appetite declines, often we become less physically active, so we need to consume less energy, but we still have the same micronutrient requirements, and so our diets actually need to be more nutrient dense. So actually diversity in the diet as you get older is really, really important. I think one of the concerns with older adults, so older adults often carry with them those messages about having low-fat foods and having we must follow a low-fat diet. And in actual fact, older adults, it's really important that they are meeting their energy requirements, and they need a really diverse diet. And so, no, I don't think there are any food groups that are particularly harmful as we age. I think in terms of foods that are helpful, it's that message of, eat the rainbow of foods and try and have as diverse a diet as is possible, with lots of plant-based foods, lots of vegetables and fish in there. And as Ellie says, it's not that, not for 1 minute I wouldn't advocate, I'm not saying go vegetarian at all and exclude meat from the diet. And meat is a really important source of iron and B12 for older adults. But it's about having moderation and variety in the diet.
Okay, thank you. And I have another question. This is coming from Lynette. So what is the experience of working collaboratively across in different fields? Obviously, these institutes are all very interdisciplinary. So how do you find that, and have you experienced that before? Maybe we can start with Alastair here.
Yeah, I mean, my background is actually kind of in industrial R&D, and their industrial R&D is all about interdisciplinary working as much as it is in university. So throughout my entire, I guess, working career, this is my experience is working with different people with different skills, with different backgrounds and experiences. And I think that without that experience, you can't really hope to solve any of these kind of issues, or not even solve, but even start to investigate them, because you need complementary skills and experiences to even be able to frame the problem, to be honest. In terms of university research, I've worked with researchers from geography and engineering and architecture, and that's because energy is a kind of, it spans all across the kind of focus of these different disciplines. And archaeology, actually, we're looking at energy historically, and it's much more interesting to do research that is interdisciplinary. Yeah.
And Ellie, what's your views?
Well, I would say my experience so far is quite humbling, actually. I think working with, so I work, for example, on one project with a social scientist, and we are working with, or at least trying to understand better farming practices. And the social science side is bewildering, because I have to learn a whole new kind of language. But but working and talking with farmers is the bit that's quite humbling, because you step out of your kind of academic bubble and you realize what your place in this network is, and it's not as big as we perhaps like to think maybe it is as academics, and that there's so much to learn, and we really are quite naive as to how things actually work on the ground. So coming from someone who is purely working within academia to being confronted with the real world, it's a bit of a shock. It's good.
Thank you. So I think we are nearly getting towards the end. So I would like to ask a final question to the panel. If you could sum up in one sentence what you'd like your viewers to take away with them tonight, what would that be? And I'll start with Francesca.
Okay, so I will say age-related hearing loss is a complex disorder with a genetic and an environmental component. We are working to try and tackle the genetic part by developing diagnostic tools and treatments. What you can do is work on the environmental part and look after your ears. So avoid standing close to speakers or wearing headphones for too long time. And hopefully with both these tools, we will tackle this challenge.
Thank you. Liz?
In one sentence, I would say that it's never too early or too late to improve your lifestyle. So improve your diet, increase your physical activity, quit smoking, drink less alcohol. It's never too early or too late to make those changes to improve your health and increase your chance of a healthy older age.
Ellie?
Okay, well, I would say that that we have a serious issue on our hands in terms of agricultural sustainability, and it's something that needs system change. It's a hugely complex process, it's beyond individuals to fix, but it's something that we can all collaborate in, thinking about where you get your food, the kind of foods you eat, whether or not you're wasting food on a regular basis. It's a major challenge, but hopefully we can all tackle it together.
And finally, Alastair, you have the last sentence.
Okay. So maybe we've made more progress in decarbonising electricity than you might have thought, but there's a huge amount of work still to do globally to address climate change.
Fantastic. So I'm afraid that is all we have time for. If you'd like to learn more about the Institute, you can follow the links on the screen. Thank you all very much for tuning in this evening and for all your interesting questions. Thank you also to our wonderful speaker, and have a good night.